White shrimp Penaeus baneme. White shrimp Penaeus baneme, this species is also known as Pacific white or white-leg shrimp. Its original range was from Gulf of California southern to northern Peru, but this is now cosmopolitan species. Male reached a total length of 187 millimeter and females is 330 millimeter. So, itong white shrimp Penaeus banime daw is alam natin sa na Pacific white or white leg shrimp. Ito ay nagmula sa Gulf of California southern to northern Peru. Next is black tiger shrimp, Penaeus monodon. Penaeus monodon is the largest 363 mm maximum length and faster growing up to 5.5 grams per week. Of the farm shrimp, the species is native to the Indian Ocean and the southern Pacific Ocean from Japan to Australia and dominant production everywhere in Asia except for Japan and China. So, hindi ko na muna i-explain to isa-isa. Mamaya na ako mag-explain after kong basahin lahat to. Doon na sa pinakang huli yung explanation at kabuuang pagpapaliwanag. Extensive system, low stocking densities. Shrimp farms with low stocking densities are typically located in tropical water impoundment ranging from carbohydrates to H25 are located adjacent estuaries, bays, and coastal lagoons and rivers. They frequently involve polyculture with herbivorous species such as mullet, milkfish, tilapia, and others. Semi-intensive system, medium stocking densities. Shrimp farms that operate the medium stocking densities are built about the high tide line and include pumping station, water distribution canals, reservoirs, and use of formulated feeds. In general, farm layout is relatively more symmetric than intensive farm and food are harvested by draining through a net or by using a harvest pump. Intensive system, high stocking density. Shrimp farms use intensive culture and high stocking densities typically have fund of 0.12. Although various design of raceways and above ground tank are also used, sometimes is greenhouse or hard buildings. Pond is frequently lined with high density polythene, HDPE, or other commercial plastic inert liners. Intensive system, very high stocking density. At the upper ends of the continuum system with very stocking densities include the highest level of environmental control to the point of some being located indoors with greenhouse and other structures. Preparation of ponds. Adequate ponds preparation provides young shrimp with an environment that is relatively free of predator and competitors with an ample supply of adequate natural foods, organism, and environmental condition that minimize stress and promote growth and survival. Pond draining and sludge disposal. Effective removal of sludge that has built up on the pond bottom over a prior craft cycle is a very important step. If not removed, I will become anaerobic reduced sediment. Pond drying and pH mapping. Earthen ponds must be allowed to dry out for 2 to 4 weeks to promote decomposition of organic matter by bacteria. Eliminate pathogens and eggs, larvae, and adults of predator and competitor. And dry out undesirable filamentous algae. Disinfect. Disinfect is important to eliminate eggs, larvae, juveniles, and adult of species of fish, crustacean, insect, and other predator and competitor species. Several commercial products have been used to disinfect pond before stocking shrimp. Liming. Liming pond bottom is critical step in preparing earthen ponds. When calculating liming requirements, the type of lime product is used must be considered as this will influence the amount of requirements. Wear gate preparation and entrance screening. Configuration and replacement of wear gate, restriction board, and screen to prevent escape and entry of predator while at the same time allowing water to enter and exist continuously is vital for cost-effective product. So, kailangan natin din gumamit ng entrance screening para hindi makadapo yung mga ibon na maaring magdala ng sakit na maaring makahawa sa mga ipon. Natural productivity. Proper management is natural productivity in shrimp ponds is critical to promote and sustain plankton blooms and microbial and benthic community productivity. Initial fertilization. Fertilization of shrimp pond is an effective means to stimulating natural food production that can help reduce feed cost. Through fertilization, manager can promote those pond ecosystem components that are beneficial to shrimp production and discourage those are that detrimental. Reproduction and maturization. Hatchery reproduction and the life cycle. The typical life cycle of shrimp in nature begins with adult animals migrating up to several kilometers offshore, maturing, mating, and spawning. The eggs initially sink, but after a few hours, they hatch and now flee the first larvae stage, float to the surface. Broodstock maturization. It is very important to be able to reduce seed stock on demand consistently and in sufficient numbers to support the industry. Maturization of shrimp's broodstock is undertaken routinely. Often versus closed Deliicum species. Pinnate shrimps belong to the two groups based on the structure of the female Deliicum, a receptacle structure on the ventral thorax of females where the spermatophores is deposited by the male at mating. Maturization reproduces. The maturization process is relatively simple and includes selecting of resourcing good prospective broodstock, screened of absence of viruses, and holding them under stable, optimal environmental conditional, minimal stress and adequate nutrition using both natural and artificial diet. Mating and spawning. Mating in shrimp is characterized by particular courtship behavior and various pheromones and involved in sex attraction. Females with one or both eye stalk ovulated will normally spawn multiple times over a period of several weeks. Hatchery design and larval culture hatchery design. Shrimp hatcheries may be set up in a warehouse structure of building shelf and have indoors and outdoors infrastructure and facilities. Larval culture method. Worldwide, various methods are used to produce shrimp larvae in hatcheries. These are all modifications of two basic methods, the Taiwanese and the Galveston methods. Larval nutrition. The larval feeding regimes of shrimp hatchery is typically based on the microalgae and brine shrimp on a live feeds combined with a formulated preparation diet. Probiotics, vaccines, and immunostimulants. The ability to control pathogenic organisms, particularly bacteria, has been very important to success to commercial scale hatcheries. Seed stock quality and stocking, seed stock packing, transportation, and reception. It is very important that the delivery of seed stock PL is well coordinated between the hatchery and the farm. Good planning and communication are required to ensure a smooth transition for the protected condition of a hatchery to the condition of an outdoor farm, tank, and raceway. Counting and quality control. There are various methods used to count shrimp PL, and there is controversy regarding the accuracy of each. Volumetric subsampling is a most common technique. Acclimation and stocking. Most shrimp farmers spend substantial resources and effort during fund preparation to enable them to stock their PL in a growth environment with a best position environmental condition. Production management and harvest. Water and sediment quality. Some water quality parameters must the routine monitors to effectively manage shrimp production system during growth out. Controlling various parameters can be difficult, but if not managed properly, pond carrying capacity can be rapidly exceeded. The fund can cross within a few hours or days. Water management. Water exchange is an effective management tool to flush out waste and some cases it's to improve DO level. Water aeration and circulation. Pond aeration is the primary life support system of many culture ponds including shrimp ponds. Population sampling and health assessment. Periodic samplings of shrimp population is an important management tools during the production cycle. Cast netting is about the only effective sampling to currently available and it's widely used. Harvest and transport to processing plant. Shrimp are highly perishable and delicate, and no amount of manipulation can be restored product quality once it is lost. Nutrition, formulated diets, and feeds management. Nutritional requirements and formulated diets. With industry expansion, there has been intensification of production and an increased dependence on the use of manufactured dry feeds, which often represented the highest production cost. Feed management. Shrimp feeds management is a critical respect for cost-efficient, environmentally responsible shrimp production. Factors that affect feed consumption. Several factors can affect shrimp feeding behavior, and it is important to understand these factors to make proper and timely management adjustment. Next is feed handling and storage. Feed management at a shrimp farm begins upon arrival of a feed shipment. Poor storage and handling of feeds will result in product deterioration, reduced feed attractability and potability position, nutritional deficiencies, and disease outbreak, reducing growth rates and overall production. Application and distribution. Formulated feeds may be distributed manually in large ponds from boats or mechanically using blower-mounted and vehicle and boats. Frequency and timetables. Or formulated feeds have an ideal feeding rate change that optimizes growth and feed efficiency. Feed rations. Feed rations can be calculated using the set schedule that account for animal weight and estimated biomass survival in the pond. Use of feed trays. Feed trays are also called observation or lift net, feed inspection tray, in umbrella net. Emerging production technologies and issues. Disease and biosecurities. Viral disease have a considerable impact on commercial shrimp farming during the 2 decades, significantly affecting the operation, management, and design of the shrimp farms. Probiotic and microbial management. As I described, the use of probiotics is relatively common to limit pathogenic bacteria in the disease-prone intensive system to use produce shrimp PL in commercial hatcheries. Nursery system. Many shrimp farms are now use nursery system as an intermediate production step between the hatchery and the final grow-out pond. Inland shrimp production. Shrimp farms are traditionally built in the tropical coastal areas, very close to the ocean or to an estuary or river. Recirculation, biofloc technology, and reduced water exchange system. Improved water management regimes can help address viral disease problems and issues raised by environmental groups that have targeted shrimp farming, pressuring the industry to adopt more sustainable production practices. Responsible shrimp farms and the challenge of sustainability, domestication, and genetic improvement. During its first 3 decades, commercial shrimp farming depended significantly on wild seed stock and brood stock. Nutritional requirements and formulated feeds. The development and use of compound feed have been major factor in the expansion of the industry and will continue gaining importance. Disease prevention, diagnosis, and control. As described earlier, there have been spectacular collapses of shrimp farming industries in a number of countries, including the top producing countries China, Thailand, Indonesia, and Ecuador. Best management practices. Best managed practices, or BMPS, are a practical way to approach environment management for shrimp farming. So, isa ang white shrimp o suwalis sa pangunahing aquatic species na inaalagaan, particular sa mga brackish water fish pond sa Pilipinas. Ito ay tinuturing na isang high-risk, high-work species dahil sa maselan at mabilis silang kapitan ng mga sakit. Kung ating susundan ang mga tamang pamamaraan sa pag-aalaga nito ay malaki ang maaari nating kitain sa pag-aalaga ng hipon. Sa kasalukuyan, malaki ang demand para sa suwahe ng ating bansa dahil sa mataas na presyo ng fry meat na ito ang pag-aalaga ng hipon, isang negosyo na maaaring pagkakitaan. So, mahalaga na ang pipiling lugar na pag-aalagaan ng hipon ay siguraduhin may supply ng tubig tabang at tubig dagat. Dahil ang hipon ay inaalagaan sa brackish water, dapat may magandang lupa na kayang humawak sa tubig, malayo sa matataong lugar, at kung maaari ihiwalay sa ibang fish farm, lalo na sa mga nag-aalaga ng mga hipon, upang maiwasan ang mahawaan ng sakit. Para sa paghahanda ng fund, kailangan tuyuin ang lupa hanggang magbitak-bitak ang lupa. Ito ay kadalasang tumatagal ng 15 days. So, tanggalin ang mga topsoil na maaaring magtaglay ng makakasamang chemical. Patuyuin muli ang pan pagkatapos ng 1 linggo. Ay araruhin ulit ang lupa gamit ang kalabaw o mechanical hand tractor. Magpapasok ng tubig sa pan at i-flush ang tubig upang mawala ang mga dumi. Patuyuin muli ng 5 araw bago mag-supply ng agricultural lime or apog sa rate na 5 kilo kada hektarya o 500 grams per square meter. Paglipas ng 2 araw mula sa pagka-apply ng lime, magpapasok ng tubig na may lalim na 1.5 metro. 3 araw mula pagpapasok ng tubig, maglagay ng seeds sa may konsentrasyong 20 ppm para mapatay ang mga isda na maaaring nakapasok sa ating pond. Maglagay ng disinfectant na may concentration na 1 ppm. Pagkalipas ng 3 araw, maglagay ng mga aerators depende sa stocking density ng ating FAD at patakbuhin ang mga ito. Mag-apply ng abono na 16:20 at 21:00 na may ratio na 3:2 na may rate na 10 kilo kada hektarya. Kinabukasan, maglagay ng pinagsalong rice bran molasses 10 kilos kada hektarya. 3 araw bago maghulog ng similya ng hipon, maglagay ng probiotics upang mapaganda ang kalidad ng tubig. Sa stocking naman, kailangan kumuha ng similya maaari sa BIFAR at VIFAR accredited hatcheries. At pumili ng similya na may laki na VL10 at VL15. May 3 uri ng stocking density na maaari nating gawin para sa intensive stocking density. Maaaring maghulog ng 5 hanggang 10 piraso kada metric of kwaderno ng ganitong stock. Ang ganitong stocking ay hindi na nangangailangan ng aerator. Para sa semi-intensive naman, maaari tayong maghulog ng 15 hanggang 50 piraso kada metric or kwaderno. Ang ganitong stocking ay nangangailangan ng isang 1 pH na aerator kada 500 to 800 kilogram na biomass. Para sa intensive stocking density naman, 60 to 500 pieces kada metric o kwaderno na ang ganitong stocking ay nangangailangan ng 1 HP na aerator kada 300 to 500 kilograms na biomass. So, kailangan na i-acclimate ang mga similya sa isang balde o stocking boxes na may aerator na tubig na nanggagaling sa pond ng ating paghuhulugan. Dapat hindi bababa sa 1 oras ang pag-acclimate ng mga similya. Dapat bilang lang yung ihulog na similya sa pond. 100 similya sa isang survival net upang malaman ang survival rate. Sa water management, kailangan ugaliin na tingnan ang water parameters. Siguraduhin na ang ating water parameters ay nasa sumusunod: dissolved oxygen higit sa 4 ppm, ammonia na hindi tataas sa 1 ppm, pH na 7.5 hanggang 8.5, then temperature na 25 hanggang 32 degrees Celsius. Salinity na 10 to 33 ppm and transparency naman is 15 to 30 cm. Mainam ang kulay ng tubig ay brown, yellow at green. So, magpapasok ng tubig sa pond kada 1 linggo at madadagdagan ang probiotic upang manatili ang mga good bacteria sa ating tubig na nakakatulong sa kalusugan at paglaki ng mga hipon. Maglagay ng tansi sa ibabaw ng mga ponds upang maiwasan ang pagdapo ng mga hipon sa ponds na maaaring magdala ng sakit na makakahawa sa mga hipon. Dapat control lang yung mga taong pumapasok sa palaisdaan or sa pond. Kinakailangan din maghugas ng kamay bago pumasok o humawak sa pond. I-disinfect ang mga kagamitan, ilayo ang post-harvest sorting area mula sa production area. Maghanda ng mga gamit tulad ng bangka, balde at timba sa bawat isang pond. Ang pagpakain ng hipon ay sa pamamagitan ng broadcast method. Mainam ang gumamit ng bangka upang masigurado na mapakain ang lahat ng hipon. Sa pagpapakain magpakain ng breast starter hanggang sa 20 days of culture na may average body weight na VL hanggang 3 grams per vis. So, dapat pakainin 2 times a day. Magpakain ng free starter to simula 21 to 40 days of culture na may average na 21 to 5.5 grams na feeding rate na 6 to 5.5% 3 times a day. Magpakain ng starter simula 40 to 70 days of culture na may average body weight na 5.5 to 12 grams sa feeding rate na 5.5 to 4%. 5 times a day magpakain ng grower simula 71 to 90 days of culture na may average body weight na 12 to 80 grams sa feeding rate na 4 to 2.5%. 5 times a day magpakain ng finisher simula 91 days of culture pataas na may average body weight na 10 grams pataas sa feeding rate na 2.5 to 1.8%. 5 times a day. Mainam mag-partial harvest kapag mayroon ng 15 grams at average body weight pang ang mababawasan ang stocking density ng pod. Gamit ang seam net, paikutin ito upang maipon ang mga hipon sa isang gilid. Gamit ang thicknet, hulihin ang mga hipon. So, ilagay sa banyera mga hipon at idala sa post-harvest area. So, kapag kayong i-harvest mo na siya, syempre, kailangan mo ng mga maayos na gamit at tamang gamit upang mapanatili ang maayos na proseso ng pag-harvest ng mga hipon. That's all. Thank you.